Okay, we're on page 12 of the 7-6 notes. I'm going to start over because I started rushing because I saw I was running out of time on the last video. So we're looking for boundary points, and you might want to write this down. Boundary points are the real solutions. So when I say solve, and it's also going to be where it's undefined, which we're not going to have in this section because we're not going to do the rational expressions, but in Math 150 you will. So in order to use the boundary point method, which is what they'll teach in 150 again, we have to find all the solutions. So I made this small so we can follow this along. So x squared plus 2x minus 8. Factors of 8 that subtracted 2 are 4 and 2. Make the largest one positive. So then I went down here and wrote x plus 4, x minus 2 equals 0. And then remember, if a times b equals 0, either a is 0, which would give us x equals 2 when we add 2 to both sides, or b is 0, which would give us x equals negative 4 when we subtract 4 from both sides. So those are my two boundary points. So I then label them on the graph. So negative 4 is labeled a red dot, and 2 is labeled with a red dot. Okay, so those are the solutions, but they're also going to be the boundary points for our different intervals. So now we have three different intervals. We have the interval to the left of the red point. We have the interval in between the two pink or red points, and then we have the interval to the right of the boundary point. And before I was using the blue ones as the boundary points. No, those are called the test points. I didn't read the problem carefully, so that's why I wanted to start from scratch. So show you where the solutions came from, mark them, and then it divides it into three intervals. First interval, second interval, third interval. So then we select a test point from each interval. So on this one, I selected the test point -6. In between -4 and 2, I pick 0. Anytime you can pick 0, pick it. And on the interval to the right of 2, which means larger than 2, I pick the point 4. So that's what this says. So we have three intervals. Select a test point from each interval. So there's my three test points. So if the test point makes the original inequality true, then that's part of the solution set. If it doesn't make it true, then it's not part of the solution set. So select a test point, blah, blah, blah. If a test point makes the inequality true, then that's part of the solution. Test the boundary points in the original inequality. If the original inequality is strict, which means less than or greater than, we can't include the boundary point, and that's when we use the parentheses. If the original inequality has an equal sign, that tells us we're going to be using brackets, because that means the boundary points are defined. Any boundary point that makes an expression undefined must always be excluded. And that's not pertinent to what we're going to do today. It's later on in the section that they do that, but we don't do all of it. So that's something you're going to learn about in the next class. But if I had, let's see, x minus 2 over x minus 4 is greater than or equal to 0. So 4 is one of my boundary points, but I can't include it because when I put 4 in, 4 minus 4 makes us undefined. So that's what it means. It has to be excluded. So we would have to use parentheses. So like I said, you'll cover that in depth in the next class, but that's what that means. Okay, so let's see how this works. And this is exactly what you're going to be doing on your next problems. So first you solve using all the methods you've learned. That's what this whole class has been about, is solving quadratics. So we factor, we find the solutions, we plot them. Then we pick a test point to the left, a test point in the middle, test point to the right. Once in a while, we'll have three solutions if there's a cubic. I did put one on the test that has a cubic, but the other one on the test is going to be a quadratic. So it'll have 2 points. Cubics will have 3, because remember how they always have the number of solutions as their highest power. So highest power 2 will have 2 boundary points. If the highest power is 3, then it'll have 3 boundary points. So now we take our test point and we plug it in and test it. So that means you take -6 and you put it up here everywhere you see x. So -6 squared plus 2 times -6 minus 8. Is that less than or equal to 0? So 36 minus 12 minus 8 is, what is that, 16? Is that less than or equal to 0? No. So that's false. And I always like to write this. I put plus because the answer came out positive. I'll show you why in a second. And I think your teachers in the next class will do that too. And I know they will in calculus. So whatever the sign of the answer is, 16 was the answer I got. I put the sign there. Okay, next our test point in between -4 and 2 was 0. So now put 0 in your original equation and you get 0 squared plus 2 times 0 minus 8. Is that less than or equal to 0? So 0 plus 0 minus 8, -8. -8 is less than or equal to 0, so that one's true. Notice this answer came out negative, so I put a negative sign right here. And I'll show you why in a second. Just play with me for a little bit, and then I'll show you the whole reason behind this. Our next point is 4. So we put 4 in, 4 squared plus 2 times 4 minus 8. So 4 squared, I'm kind of off the paper. So 16 plus 8, 24 minus 8, 16. There's another positive answer. So I put a plus sign there, and that's false. 16 is not less than or equal to 0. So let me show you why I just did that. So this says, when is the graph less than or equal to 0? Doesn't less than or equal to 0 mean it's negative? Does everybody agree? If a number's less than or equal to 0, it's negative. So this is why I put the signs on here, because the negatives, if there's 2 negatives, 3, 4, all those intervals are my solution. So on this one, the negative is only from here to here. This time we do have an equal sign, so we're going to use brackets. So we do bracket -4, comma 2, bracket. So that's what the solution set looks like. And you can see down here, I wrote the same thing. So you look at your original problem, and this wants to know when are the values less than 0, which means negative. So they are negative from here to here. So there's my solution, -4 to 2. Why did I use brackets instead of parentheses? Because of that equal sign. Okay, ready to practice? So we're going to do this on cubics and above. On parabolas, though, we know how to draw a parabola, so we'll be drawing the parabola on the graph. But on the cubics, we'll use this test point method, and you'll use it in the next class too. Okay. I love this. It's really fun. It's one of my favorite parts of 150. Okay, let's practice. So this first one wants to know, when is the inequality below the x-axis or on? And the reason I say on is, see that equal sign? So when is the graph below or on the x-axis? So remember what we wrote on the first page. Less than is below, greater than's above. It's like common sense. If you're less tall than someone, you're below them. If you're taller than someone, then you're above them. So less than is below the x-axis, greater than's above. And the reason I wrote or on is because of that equal sign. And you might even want to remind yourself this problem's going to get brackets because of that equal sign. Okay, so step number 1 was x plus 3, x plus 5, and we solve it to find the test points, the boundary points. So factors of 15 that add to 8 are 5 and 3, all signs positive. So then we say x plus 3 equals 0 or x plus 5 equals 0. So my two solutions are going to be subtract 3, x equals -3, and subtract 5, x equals -5. So remember, those are my boundary points, and they must be in order on the number line. Don't just put -3 here and -5 there. It goes 0, -1, -2, -3 would be on the right, -5 on the left, because this is a number line and you have to treat it as such. You need to make sure that the numbers are in the correct order for the number line. So because there's an equal sign, we can put solid circles there at the x-axis. So this number line is our x-axis. So at this point, you could do test points like we did on the last page, or you can go, oh, well, I know how to draw a parabola. That's a parabola that cups up. So you could draw a rough sketch of a parabola. And what that's going to tell you, now we have to pick the region that we want. This wants to know, when is the parabola below the x-axis? So I'm going to take another color pen here, and below would be right here, right? So what x values go with that? Well, all the x values from here to here, because it's only wanted below because it's less than or equal to. So what's my solution? Brackets, because of the equal sign, bracket, -5, 2, 3, bracket. So this is saying, when is the parabola below or on the x-axis? It's below or on the x-axis from x values -5, to -3. Good thing I went back and re-explained that. I covered up my negative and forgot about it. So from -5 to -3 is when my parabola is below the x-axis. So I say you should turn off the video and try number 3 on your own. Then turn it back on and we can check our answers. Okay. Okay, this one wants to know, when is the parabola above the x-axis? So first I have to find the solutions, and this is an on. Notice there's no equal sign, so if you want to remind yourself that there's going to be parentheses instead of brackets, that's a good idea. So factors of 28 that add to 11 would be 7 and 4, x plus 7, x plus 4, greater than 0. So now, or equal to 0, we're trying to find the solutions. So either x plus 7 is 0 or x plus 4 is 0. So subtract 7, you get x is -7. Subtract 4, you get x equals -4. So 0, -1, -2, -3, -4 is to the right. And -7 is smaller, so it should be to the left. This time, we can't put solid because there's no equal sign. So this time we're going to have open circles, which tells us to use parentheses later. And again, this is a parabola, so we can do a rough sketch. We know what parabolas look like later on. When we get to the cubic one here, We don't know what it looks like yet, so we're actually going to have to do the test point method. But when you